Now in the last video we have looked at the three methods for preparing salts, and then for each salt which method to use, and also the recommended starting reagents for each method. So in this video we're going to look at the steps involved for each method. So the first method that we're going to look at is the precipitation method, and a quick revision: precipitation is for insoluble salts, okay, and the starting reagents would be two solutions, okay. So the two reagents that you add must be soluble. So over here the salt that we want to prepare is barium sulfate. Okay, barium sulfate is insoluble, so we need to use the precipitation method, and the starting reagents, in this case the recommended one would be barium nitrate and sodium sulfate. So now we're going to see what we need to do to barium nitrate and sodium sulfate in order to prepare a pure and dry sample of barium sulfate. So once again, the two reagents are barium nitrate and sodium sulfate. Okay, so the first thing that we need to do in the precipitation method is that we need to mix the two solutions together in a beaker. Alright, once you add the two reagents together, immediately you will see a solid coming out. So we will continue to stir the mixture until no more precipitate forms, okay. And then after that, what we will get is this: we will have your barium sulfate form as a precipitate in a solution. So how do we get our barium sulfate now is that we need to perform a filtration. Alright, so we need to perform a filtration, and where do we get our barium sulfate is that we get it in the residue. Okay, so we get our barium sulfate, filter to obtain the precipitate, and now that we have your barium sulfate, the thing is that it's still not very pure because there will be some solution. There will be some solution that's stuck to your precipitate. So what we need to do next is to wash it with a little bit of cold distilled water to remove the impurities. And after that, we need to dry the precipitate either by pressing between pieces of filter paper or allowing it to dry in air. Okay, so the steps for precipitation is rather simple, and to help you all to remember it, what you can do is you can represent each line by just one word or phrase. Okay, so step number one is mix. Okay, we need to mix the two reagents, and then after that stir, and then filter, wash, and then dry. Okay, so these are the steps involved for precipitation. Now one extra piece of knowledge is this: why do you need to wash with some cold distilled water? Why can't we use normal water? Why can't we use a lot of water? The reason is this: no matter how insoluble a salt is, right, it has a certain extent of solubility in water, right? So if you use a lot of water, we will still lose a bit of our precipitate because it dissolves to a very, very small extent in water. Alright, and you would have learned that solubility of a compound in water depends on temperature. If you use hot water, more of your precipitate is going to be dissolved when you are washing it. Alright, so the purpose of using cold distilled water and only a bit, some means a bit, alright, is that we want to avoid losing too much of the precipitate to dissolving during washing. The next method that we'll look at is the excess method. Again, excess method is for preparing soluble but not spar. Okay, so over here we are looking at zinc sulfate, and the recommended starting reagents for the excess method is an acid with excess of an insoluble solid. So the acid here is sulfuric acid. The excess solid can either be zinc, the metal, the carbonate, or the oxide. Okay, so since there's no restriction, I would recommend using the carbonate. So over here, we are looking at zinc sulfate. So add excess zinc carbonate to your dilute sulfuric acid. Okay, so first step in the excess method is to add excess of the solid to the acid. Okay, we need to heat the mixture gently. Alright, why is to make the reaction go faster. And then we need to stir until no more effervescence is observed. Alright, this is for the metal or the carbonate. Why? Because when metal reacts with an acid, it produces hydrogen gas. When carbonate reacts with an acid, it produces carbon dioxide gas. So when these gases escape, we will see them as bubbles or effervescence. Right, that is also why it's recommended to use carbonate, because we will know when the acid is fully reacted, because we will keep adding carbonate until we see no more bubbles. That tells you that there's no more reaction. Okay. However, if we are using a metal oxide, then you will not be seeing bubbles, so you just stir until no more solid can dissolve. Okay, the purpose of which is to ensure that all your acid has been reacted. Okay, this is a very important step for excess method. Ensure that all acid is reacted. Okay, so at this point in time, what do we have again? We have the salt being formed in solution already. We have zinc sulfate. Okay, we have zinc sulfate present in solution, but we have excess of the solid, remember, that's unreacted. So the next step is that we need to remove the excess solid. So we need to perform a filtration as well. But the thing about the filtration now is that we want the filtrate, we don't want the residue. The residue contains your excess solid, which we want to remove. So we collect the filtrate, and what do we have in the filtrate? We have your zinc sulfate that is dissolved in water. Okay, we have a zinc sulfate solution now. So when we have a salt that dissolves in water, how do we get back the salt? In the topic of purification and separation, for a solid soluble in a liquid, the way to get it back is by performing a crystallization. Alright, so from steps 4 to 8, essentially we are doing a crystallization separation. Okay, we need to heat the filtrate until it's saturated. Okay, and then we allow the filtrate to cool, and then crystals will form, and then we filter to obtain the crystals, and then we wash and dry again. Okay, so for the excess method, what we need to do at the very start is to add excess solid to the acid, ensure that the reaction is complete, and then we filter to remove the excess solid. After we get the solution, we need to perform a crystallization in order to get back the salt. Alright, so add excess solid to acid. This is the first step. Then the next step is to filter to remove excess solid, and then after that we need to perform a crystallization on your filtrate. So in a nutshell, the excess method looks like this. Now the last method is the titration method. The titration method is the most complicated of the three methods. Okay, so quick revision again, titration method is for soluble sparse salts. Okay, and the starting reagents would be an acid with an alkali. Okay, now the difficulty with the titration method is this, that in order to produce the salt, we must add exactly the exact amount of acid with alkali, the exact amount such that they are reacted. That means we cannot have too much of one or the other. It must be just nice. Okay, we need to mix or add the exact amount of acid and alkali such that both are reacted completely. Okay, so how do we do that? How do we know that we have added just nice amount of acid to react away all the alkali, or vice versa? Is that there's actually an experimental technique, and the experimental technique is called titration. Okay, in a titration, we put one of the reagents in a burette. So for example, I can put the acid in a burette, and then I put the other reagent, the alkali, in a conical flask. Okay, so what do I do is this. I will use an indicator, a pH indicator. We have learned pH indicators, okay, to tell us the pH of the solution. Okay, so a typical indicator that we use is called methyl orange. Methyl orange. Okay, methyl orange has the three colors. It is red when acidic, it is orange when neutral, and it is yellow when alkaline. Okay, so if I add the indicator to the alkali, what will happen is that I will have a yellow solution now. Okay, so I will start by adding bit by bit of acids into the alkali. So I will open the burette and I add a bit at a time of acid to the alkali. Right, there will come a time when one drop of the acid turns the color of the solution to orange. Okay, so it will be turned from yellow to orange. Okay, when the color of the indicator change from yellow to orange, what does it mean? It means that that one drop of acid has led to all the alkali being reacted. Meaning at this point, we have added just nice the exact amount of acid required to react away all the alkali in the conical flask. All right, this we call this the end point. Okay, so the point where the indicator changes color, that's called the end point. What does it mean? It means that we have added just enough acid to react away all the alkali in the conical flask. So by using titration, we can find out what is the exact amount of acid to add to the alkali. Alright, so that's why this method is called the titration method. So let's look at the procedure for the titration method. Now it's important for you all to know that the titration method is divided into two parts. Okay, in the first part, we need to find out how much acid do we need to add to just nice react away the alkali. And as described earlier, we can use a method called the titration method together with an indicator. So the steps go something like this. We need to pipette 25 centimeter cube of your alkali. So in this case, we are looking at sodium nitrate. So the alkali is sodium hydroxide into a conical flask, and then we need to add 1 to 2 drops of indicator into the solution. Next, we titrate, or we need to add the acid. In this case, is nitric acid from the burette until the indicator changes color. Right, so in this case, if we are using methyl orange, it will change from yellow to orange. And now we need to record the volume of acid required. Okay, so for example, the indicator changes color when I've added 20 centimeter cube of acid. Then you need to note down. What does it mean? It means that we need 20 centimeter cube of nitric acid to just nice react or neutralize with the sodium hydroxide. So at this point, when we have added 20 centimeter cube of nitric acid, we have just nice, so we don't have excess of nitric acid or sodium hydroxide. So now that we are complete with the first part, we know that we need 20 centimeter cube of nitric acid. So we move on to the second part of the titration method. In the second part, now we prepare the salt. Okay. Previously, we have learned that we need to add 20 centimeter cube of the acid. So we repeat the titration, but this time, the important thing is this, that we do not add the indicator. Why? Because the indicator will contaminate, it will be an impurity in your salt. So in this case, we already know how much to add, so there's no need for indicator. Alright, we just add 20 centimeter cube of the acid to 25 centimeter cube of the alkali, and then that will give us the salt solution. Okay, that will, after adding, immediately what we have would be a solution of sodium nitrate, nothing else, just sodium nitrate dissolved in water. So if we want to get back the solid that's dissolved in water, once again we need to use the crystallization method. So over here, steps 4 to 8, we are looking at crystallization once again. Okay, so for titration method in a nutshell is this: we need to first perform a titration with indicator. Okay, so the purpose of which is to find out how much acid to use, and then we do another titration. We repeat the titration without indicator, because now we already know how much acid to add, so we just add, and then lastly we perform a crystallization. So we have seen the procedure for the 3 different methods, your precipitation, excess, and titration. I know the steps may be quite lengthy, so it will be good for you all to have an overview of the steps, and then the overview will help you to recall the exact steps for each part. So a typical question that you may get in the exam is this: state how you can prepare a pure and dry sample of sodium nitrate. Okay, so for example, if you get a question like this in the exam, the first thing you need to do is to find out which method to use. So sodium nitrate is a soluble spar salt, so we need to use the titration method. And then you need to ask yourself next, what starting reagents do I want to use? Since it is a spar salt titration method, we need to use an acid reacting with an alkali, so we will use nitric acid and sodium hydroxide. Then the last thing is to recall the steps for performing the titration method, okay, and write everything down.